Good morning, my dear students. So in the last class, I just started with the projection of pyramids. I think we solved the problem on pyramids on a square-based pyramid. Okay, so in today's class, let us just switch on to the pyramids concepts only. So let me take different pyramids and we'll go to solve the different types of problems. Okay. So in that respect, so today I will going to start with Were you able to see the slide? Ayush?
Yes, sir.
Okay. So we're going to start a problem. Please make a note of this problem here. See, one of the most important problem from the examination point of view. So this is a pentagonal pyramid, 25 millimeter sides of base and 30 millimeter axis length, rests on HP on one of its edges of the base. Draw the projections of the pyramid when the axis is inclined to HP at 45 degrees and VP at 30 degrees. So here, a pentagonal pyramid, 25 millimeter sides of base and 50 millimeter axis length, rests on HP on one of its edges of the base. So the initial position, we need to start with the solid resting on HP with one of its edges of the base, and we need to complete the top and the front views of the corresponding position of the solid. And in the second, what they say here is when the axis is inclined to both HP at 45 degrees and at VP at 30 degrees. In this case, the axis is inclined to both HP and VP. So when I was discussing the prisms problem, I think I just have explained. So how we have to consider the problem when the axis of a solid is inclined to both HP and VP. So this is the problem. What this says is the axis of the pyramid is inclined to both HP and VP. So of course at HP it is inclined at 45 degrees and at VP it is inclined at 30 degrees. So this is the condition where we can make the problem or we can consider the problem as a candidate big angle. So and also when you look at here, there is no word appears to be in the problem statement, and definitely it will constitute a big angle problem for us. Okay. So therefore, so when the axis of a solid is inclined to both HP and VP, and the word appears is not present in the problem statement, then we need to solve the problem, either whether it is a planes or whether it is a solids. So it is the beta angle. Okay, so we have to complete the projections by taking the beta angle, and finally we have to get the projections. Okay. So now the conditions here is the solid is resting on HP on one of its edges of the base. So you can draw the top and front views in the initial position. And in the second position, we have to satisfy the condition that axis is inclined to HP at 45 degrees. We have to draw the corresponding top and front views. And the third condition is the axis already inclined to HP. It is also the same is inclined to VP at 30 degrees. When it comes to third position, so we have to consider the candidate for the final problem. Okay. So this is the problem what they have given, and we are going to look at how to do the projection of this. So now we have a pyramid which is inclined, which is resting on HP on one of its edges of the base. So now, so in the top, you can see the true shape and true size of the base of a pyramid. So therefore, so we are going to start with the top. So in the top view, you construct a pentagon first. Okay. So construct a pentagon for 25 millimeter side such that the edge of the base, one of the edges of the base should be to your line. Okay, so this is how they have constructed the pentagon here. A, B, C, D, E. So this corresponds to the base of a pentagon or pentagonal based pyramid. So where A and E corresponds to the base edge, which is resting on HP. Okay, so now, so once you complete the base edge or pentagon, regular pentagon of 25 millimeters, right? So in the last class I told you, so when you observe a pentagon resting on HP and the same pentagon if you have been viewed from the top, so you can see the slant edges. The slant edges in the sense the pyramid is made out with the triangular faces. So these triangular faces will arises from the each edge or each side of the base, and it will going to meet at a common point, what we call it as the apex of the pyramid. Okay, and so apex. So in this case, when you observe the pentagonal based pyramid is resting on HP on one of its base, and the same has been viewed from the top. So you can see the complete base, which is a pentagon, and also you can see all the triangular faces. So all the triangular faces can you see in the top view. So therefore, so here observe here. So when you draw a pentagon for the top view, so it is mandatory to join the slant edges. Slant edges, how do you draw the slant edges? Means, so you have to draw the perpendicular bisectors of a pentagon. So in the sense, so perpendicular bisector means what? A line which joins the corner to the midpoint of the opposite edge. Right? So you have to join all the five. Here you have to join all these, you have to draw all the five perpendicular bisectors, and at that point where all the five perpendicular bisectors will meet, so that will be considered as a vertex or apex of a pyramid. Okay? So therefore, in this case, so when you draw a pyramid, so be careful, this is very, very important when you are projecting a pyramids. So the top view you have is mandatory to show the slant edges or the triangular faces in the initial position. So how do you show that? So you have to join the lines or the vertical or the slant edges which from the each corner of the pentagon, each corners. Okay, so you have to draw a perpendicular bisector. The perpendicular bisector from this one corner to the midpoint of the opposite end. So that you have to draw now, and then when all this, the line you need to make dark or thick is only till where the line will going to be touching the, or it will going to intersect, see from here to here. See, from when you start at drawing a perpendicular bisector from O to, sorry, E, you go to draw from O, sorry, E, you start drawing the perpendicular bisector. So now where it will going to meet the point or the meet the other perpendicular bisector which starts from A. So like that, each you have to make it as a thick or a those slant edges shall be made thick. These lines should be very thick. So you have to draw from O to E or E to A, E to O, or A to O, B to O, C to O, and D to O. Like this, all these slant edges should be drawn, and these lines only should be, these lines are called the perpendicular bisectors. Only till where it intersects the other perpendicular bisectors, so you have to make those lines thick. Okay, and if you are drawn the perpendicular bisector means then you can erase those things, and that will constitute the top view of a pyramid in the initial position. So now we have to see this is the triangular faces. You can see O, B, E is a one triangular face. You are observing from the top. Please remember you are observing from the top, and similarly O, A, E is another one triangular face. Like that, all the triangular faces you can see All the triangular faces you can see in the top view. So this is how you can complete the top view or in the initial position. So this is these slant edges should be shown in the pyramid. It is mandatory. Please don't forget. Okay. So once you complete the top view, then you can project it for the front view. So how do you do this? Same thing. So just project the axis and from each point. So you can draw the vertical projectors, which means at the XY line. But the axis point where you have got the point O1 as an axis for us, that axis length will be given as 50 millimeters or 60 millimeter. So measure 60 millimeter or 50 millimeter and draw the line. So draw the vertical line. Then from each point where you are marking it as A dash, B dash, C dash, D dash, E dash on the XY line, the projectors, then from there you join to the apex, which is O dash. This is constitutes the slant edges point. Okay, so this will complete front view of a pentagonal based pyramid. So please remember, so when you draw a pentagonal based pyramid or any kind of pyramids, so this kind of, that is, you can see the two triangular faces. See, when you just observe this pentagon in this direction, you can see the triangular face OBC, and also you can see OAB. These are the only two triangular faces can be seen in the front view. Okay, so same thing you can just justify over here. So you see here O dash, B dash, and C dash in the front view. This is being shown as the triangular face which is visible. In the similar way, O dash, A dash, and B dash. It is another one triangular face which can be seen in the front view. So only these two triangular faces can be seen in the front view. So this is the completion of the front view in the initial position. The rest of the points, if you take D dash and E dash, because E dash will go into coincides with A dash and D coincides with D. So therefore, B coincides with D. So therefore, so these 2 points, A and B, will be written in the parentheses. So this is what we call it as the initial position of a pentagonal based pyramid, which is resting on HP with one of its base edges. The most important thing is, so the edge should come to your right. So please make sure that, so when you are constructing in the top view, the edge should come to your right and you have to complete the initial position. Okay? Next, once you complete the initial position of this solid, the second thing here is the solid is inclined to, axis of the solid is inclined to H. The axis of the solid is inclined to H. So what's happening in this problem is, I think some mistake is here, it is here 45 degree and here the action is 40 degree. Whatever it may be, that forget about the problems and this one. So just understand the procedure here, whatever it might be here. So now we have to satisfy the condition that the axis of the solid is inclined to HP at 40 degrees or 45 degrees. It is 45 degrees. So 45 degrees. So in such case, how we have to do the same procedure how we discussed for the results. So the axis has to be shown inclined to HP at 45 degrees. So here, so we have to tilt the solid in such a way that the edge, the base edge, AE should be resting on HP. So this is the mandatory condition. You cannot lift the solid above the HP. So you have to rest the solid only on the HP. How you can ensure that the base edge should be on the XY line or base should be on the HP. So in such a way that, so you are going to tilt the solid so that the axis of the solid makes an angle of 45 degrees with respect to HP. Okay. So how do you satisfy this condition? So therefore, you take a convenient distance from the front view, mark first. First, you mark a point on the XY line, which should be A dash and E dash, the base edge. Mark it. Okay. Then, so you have to draw the axis, or you have to satisfy that the axis is inclined to HP at 45. So how to show that? So therefore, what you do, what I told. So directly you cannot show the axis inclined. So first we have to construct this the front view of the pyramid over here. So for that, first you have to mark the point A dash and B dash here. So now you can take the edge C dash and A dash. Okay, so C dash and A dash, which is perpendicular to the axis, right? So C dash and A dash is perpendicular to the axis. If the axis is inclined to HP at 45 degrees, means this edge C dash, this line, we can say that as line C dash and A dash is also inclined to HP at an angle of 90 minus the angle of inclination with respect to the axis or with respect to the HP. Therefore, so if the axis is inclined 45, in this case, what's happened? Axis is inclined to HP at 45 degrees. Therefore, the line C dash and A dash is also inclined to HP at 45 degrees. So first you construct this line C dash A dash. Construct C dash and A dash this line. Then we will going to get a reference to construct this front, or you can transfer the front. But be careful that the angle of inclination of this line C dash and A dash should be always at an angle of 90 minus at what angle the axis is. Okay, so if the axis is inclined at 50 degrees, so it should be, the line should be inclined at 90 minus 50, it should be 40 degrees. So please remember that. Okay, if it is 45, not an issue. If it is 40 or 50, if they are given, so please calculate it as a 90 minus the angle of inclination with respect to HP, and with that angle you have to draw the line C dash and A dash. Okay. So in this respect, in this case, we have got the axis is inclined to HP at 45 degrees. So therefore, so draw a line. So you have drawn, you have marked the point, the edge A dash and A dash over here. With that, from that point, take a 45 degree line from in the clockwise direction. So then measure the length of A dash and C dash, draw a line and complete A dash and C dash. So once you get this line, then we can easily construct the front view of the pyramid. So how to do? So this is just like a first construct the outer triangle, which is easy for you. So we have already got A dash and C dash, and therefore take a compass and measure what is O dash and A dash and O dash and C dash. So now with using the compass, you just construct the outer triangle, that is O dash, C dash and A dash. Okay. After completing then the remaining points need to be transferred over this front. So then again take a compass, measure A dash and B dash distance. Here A dash cut this, and with O1 dash the same with the compass measure and then cut it. Then draw the line, join O dash and B dash and join O dash and O1 dash. So now this will complete the solid is tilted in such a way that the axis is making an angle of 45 degrees with respect to HP. So now after completion this, the axis what you have drawn, that you just project it back till the XY line and show that axis is inclined to HP at 45 degrees. Okay, but please don't show that this line is inclined to HP. So what they are given, the axis is inclined to HP at 45 degrees. So those show this, the axis is inclined to HP at 45 degrees. So now we have satisfied the condition that the solid, the axis of the solid is being inclined to HP at 45 degrees. So this is the corresponding front view for the solid in this position. Okay. So then once you complete this, next thing is we have to get the top view of this. Okay. So same thing. So project it, draw the vertical projectors from the each point what we have given. So draw the projector from O dash, A dash, B dash, C dash, draw the projectors, and similarly from the initial position top view, draw the horizontal projectors. So where these projectors will intersect, so you please mark the points, the corresponding points. So look at here, the vertical projector from O dash will meet the horizontal projector from O. So you mark it as O. In a similar way, the vertical projector from A dash, okay, and horizontal projector from A. So these two will going to meet at this point, mark it as A. In a similar way, Correspondingly, all the vertical projectors and the horizontal projectors where they intersect, first mark the points. Okay, so without marking, please don't join anything. So first mark the points and then so apply the rules of visibility and then you can join which lines are visible and which lines are not visible. Okay, so therefore first cultivate the habit of marking the points, corresponding points at the intersection points of the vertical projector and the horizontal projector. Okay. So once you complete marking here, next is the application of the rules of visibility. So now when you use the rules of visibility, now you are observing the solid from the in this position. So that is axis inclined to HPR 45 degrees. So you are observing from the top in this position. So now we have to look it out for what are the sides and the corners which are visible and which are not visible. So again, you have to apply the rules of visibility. The sides and the corners which are nearer to the observer are visible, which are away from the observer are not visible or invisible. You can call it as an invisible. Okay, and when you are completing the top view, so look out for the outlines. If any of the edges, if they are forming an outline, whether they are visible or not visible, so that should be represented as a visible line. So you have to show it as a continuous decline. Okay, so let us take now. So now let us go to observe the solid from the top. So from this top, so this is the front view. Now we are observing this solid in the top direction or in this direction, the y direction. So now what happens when you see this? So you can see the apex O is visible for us, or O dash is visible for us, and correspondingly the triangular face. The triangular face, there are two triangular faces which can be seen in the top. One is it is O dash, C dash, and B dash. That is a triangular face which can be seen in the top view, and also the other triangular face which is O dash, C dash, and D dash. So D dash is on the other side of the front view here, other side. So O dash, C dash, and D dash is also can be seen in the front view. So therefore, only two triangular faces can be seen in the top view for us. Okay. So now what you have to do? So when you project it, and also the edge which is away from the observer is A dash and E dash. So because this is the edge which is away from the observer, which is A dash and E dash, and the edges which comes out of these 2 points. The A dash E dash corresponds to an edge. So the 2 end points of an edge. So these end points may give rise to the other edge also. So for time being, we are going to take it as the edges which comes out of or arise out of these 2 points A dash and B dash are invisible. And in the later stage, we will just take it out whether these edges, if they are forming an outline, then definitely we have to show it as a continuous line. So now look at the top view over here. So what is happening here is see O, okay. So OB is visible for us, whether it is visible or not visible, it forms an outline for us. And BC can be seen, CD is also seen. Only the edge which is away is A dash, E dash. Am I right? So therefore, A dash and E dash, we have shown it as an invisible edge in the form of a thick dashed line. Okay? And the edge which arises out of A dash, E dash. So the one edge which arises out of A dash is another one is A dash, B dash. See here, A dash, B dash is another one. See this edge. AB, what we can see, this AB is not visible in the top view. And similarly, the another one edge which corresponds to the point B dash is B dash and D dash. Okay, so therefore, in the top view, D is not visible. Okay. And also the slant edges which arises out of these 2 points. One is A dash O dash, another one is O dash and E dash. These are the two slant edges. These two slant edges are also not visible in the top view. So therefore, while you are joining these two slant edges, that is O dash A dash and O dash E dash, it also should be an invisible edges. So I think you can understand how we have drawn in the top view over here. So O dash, O and A and E. So this is what we have drawn over here. Okay, so this is also invisible edge. Whereas O dash and E dash is completely visible for us. So we have joined, that is a visible edge in the top view. So this is OC. Okay. So this is the top view of a second position of a pentagonal based pyramid with the axis is inclined to HP at 45. Okay. So most important thing is you have to distinguish between the visible and invisible edges in the solids. So in this case, the axis cannot be shown because axis has been overlapped with the visible edge. So we can show axis in this case. So therefore, the visible edge, which is OC, that has to be shown with the continuous. So this is the completion of the second position of a solid, satisfying the condition that the axis of a solid is inclined to HP at 45 degrees. Clear? So any doubts, you can stop me at any point and you can talk to me to clarify your doubts. Okay? So because are very in the question. Only one question will be asked for 45 marks and answer. No choice. As we get the choice in the planes and lines or development of surfaces and isometric, we will have a minimal choice. But solids, it is a mandatory, it is a compulsory question for 45 marks. Question to answer. Okay. Right. So now, once you complete it, we have to move to the position. So now already the axis, that is O dash and O1 dash. So O dash and O1 dash. So if we take in the front view, the length is given as the length of the axis, right? Once this solid or axis is made to incline with respect to HP at 40 degrees, and if this axis solid has been moved from the top, definitely the length what you are going to see, it will be foreshortened, will be reduced. Now the same condition it also applies over here. So the pentagonal based pyramid, the axis is inclined to HP at 45 degrees, and in that position you are observing as axis from the top, and hence the length of the axis in the top view, and talking about in the top view, is foreshortened. Its length is decreased in comparison with the original length of the axis. The original length is 60, and when you just measure the axis length in this case, it is showing it as 45.96. Means the length of the axis has been reduced in the top view. So now this axis, that is apparent length, you can call it as an apparent length OO1, is being tilted with respect to VP at an angle of 30 degrees. Okay. So this is the case, this is the candidate problem for the beta angle. So when you are starting with the third position, when the axis already inclined with respect to HP has been again tilting with respect to VP at some angle, okay, and you are getting the word appears is not there in the present in the problem statement, then you have to take a beta angle and you have to construct a top view, and then you have to project it for the movement. Okay. So now, so I already explained how to take the axis beta angle in the prism problem. So I will explain once again here also. So what we are going to do is to take a convenient distance. I'm starting with the third position. The third position The solid will carry 50% of the marks. So if it is 45 marks, it will give around 22 to 23 marks will be given for the solid, the third position. So therefore, it will be very, very important for you to complete the third position perfectly. Okay. So now, what you have to do in the third position, so we have to show the second position top view is inclined to VP, or the axis of the solid is inclined to VP at 30. So for that, how do you do? Take a convenient distance from the XY line. Okay, take a convenient distance below the XY line. So one thing what you're supposed to remember is, and in the even a small portion of the solid should not cross below the XY line. So when you're drawing the top view, all the complete solid should be below the XY line. This is very important. So therefore, especially in the third position, so what you do, take a convenient distance from the XY line, below the XY line. So draw a parallel to the parallel line, a line parallel to the XY line. From that line, you can take an angle, and below that you can. So that you are ensuring that not even a small point of the top view will cross in the XY. Okay. So this is how you should incorporate while you are completing the third position part. Okay. Take a convenient distance from the XY line below the XY line. Draw the line parallel to the XY line, and with respect to that line, measure the angle, and below that you can construct the solid. The same thing what you can do over here is now draw a line parallel to the XY line below the XY line. Now measure an angle of 30 degrees. So because the given the axis is inclined to VP at 30 degrees, right? So take a 30-degree line, draw a 30-degree line. Okay. So on the 30-degree line, mark a point, the apex point O. Okay. Now take the actual length of the axis. The actual length of the axis you can measure the initial position front view, which is equal to 60 millimeter. So take a compass to measure the actual length of the axis O dash and O1 dash from the initial position front view. Now with that radius, now the point what you have marked as O on the 30-degree line, with O as a center, okay, so you cut this 30-degree line at the point O1. So this is a very important thing here. Okay, so you cut this 30-degree line with the radius equal to the actual length of the axis, right? So once you get this point O1, then with that O1, draw a locus line. So how do you draw a locus line? From the O1, draw a line parallel to the XY line. So just name as the locus of O1. Okay, this line should be a thin line. It should be very thin, and that will represent the locus of the point O1. That is the point of the axis on the center of the base, right? So once you mark the also draw the locus line, now you have to take the apparent length of the axis. So the apparent length of the axis can be obtained in the second position top. Okay. So now take a compass, measure the distance of the axis in the second position top. So O and O1 over here, so which is showing it as a 45.96 for the inclination with respect to 40 degree there. You know, if it is 45, if you are inclined, then definitely you will get much more less than that. Okay. So now, so you are going to measure this angle. Okay. So measure this length O and O1 from the second position top view. That represents the apparent length of the axis. Now take that radius. Now come back to the third position top view with the O as a center. The initial you are marked as a O with O as a center, and the radius equal to the apparent length of the axis. You cut the locus of O1. Okay, you cut the locus of O1. So now you join O and O1 for where that arc will intersect or cuts the locus line. So that will constitute the actual axis for us. Means the actual transfer of the axis O to O1 from second position top view to the third position top view. Now join O1. Now join O1 with the axis representation. Now project it back and measure the angle. Project it back to the XY line and measure the angle, and that angle what we measure we call it as a beta angle. Okay. So in this case, when the axis is inclined to 30 degrees, the beta angle they are giving it as 41 degrees. Okay. So just measure and check whether you are getting the angle as 41 degrees. So now this is the reference line for us to construct or to transfer the second position top view to the third position top view. Means with taking the reference as O1. So if you don't take the original length, take the apparent length, what you have found, the angle, the line which is inclined at beta angle. So that is the line which should be a reference line for us. With that as a reference, so you can transfer the entire top view of the second position to the third position. Okay, so you can transfer it in any convenient way. Which method you feel comfortable? I have explained you different methods. So which method you feel comfortable, you can transfer the second position top view to the third position with the reference line. That should be the reference. So whatever the measurements you're going to take, that should be with reference to the axis at which is inclined at an angle beta angle. So once you transfer all those points and completing the second or third position top view, now what is left out is to project it to get the final front view. So draw the vertical projectors. Okay. So beyond the XY line and also the horizontal projector in the second position front view, and mark the points where these projector lines will intersect. Intersecting point you have to mark first. So before joining, first mark the intersection point of the vertical projectors from the third position top view and the horizontal projectors in the second position. So after marking, then you have to apply the rules of visibility, and then you have to show which edge is visible and which is invisible. So now, so once you mark the points over the second, third position front view at the intersection points, now you have to observe. You have to observe the solid from the front. So I am showing in this direction. So here you are the observer, you are standing here and you are observing the solid in the front. So when you observe from the front, which are the edges and the corners are nearer to the observer or visible, and which are away from the observer will be considered as an invisible edges. Okay. So now let us take, you are standing here and you are observing the solid in this direction. So the complete base of the pyramid is visible from. So it is nearer to the observer and it can be shown as an visible edges or visible base in the front view. So therefore, so in the front view, in the third position front view, the entire base of the pyramid is visible, and hence all the edges of the base should be drawn as a continuous area. Okay. Then now we have to go for any edges which are away from the observer, which can be shown as an invisible edge. So look at here, the point D and point E. D and E are points away from the observer. So the edges which comes out or arises out just should be considered as an invisible edge, provided it does not form an outline of the solid. This is very important. Okay? Whether visible or invisible, if it forms an outline, so that has to be shown as an continuous decline only in any of the views, either in the front or on the top. So in this case, the point E and D are the 2 points which are away from the observer. Okay. And therefore, so we are going to take it as the edges which arise out of these 2 points will be an invisible edges. So what are the two edges which can arise? What are the edges which can arise out of these points? One is E and A is a one. Okay, and another one is E and B. And this is the two edges which you can see in the front view, and also C and D. CD. CD is the one. And moving on back to the slant edges. So OE is the one and OE is the other one. So these are the edges which will come or arise out of the 2 points which are away from the observer, which is D and B. Okay, and we remember that if those lines which are assuming it as invisible line, if it is not a part of an outline, if it is not a part of an outline, it should be shown as an invisible line. If it is forming an outline, so it should be as a continuous line. Let us look at over here. See here, what's happening? The complete base is visible, I already told. So therefore, you can join the complete base A, B, C, D, E, or A dash, B dash, C dash, A dash in the front view. It is a complete visible base. So we are joining all these points with a continuous line. Okay. Next comes. So let us look at, we are talking about the 2 points E and D, which are away from the observer. And now, so DE. The DE, it is a base, am I right? So it is completely visible in the front view. So therefore, you are getting it as a continuous decline. Now, what's happened to the slant edges? O to D and O to E. O to D and O to E are not visible in the front. So therefore, we are showing these two edges, these two slant edges, O dash and E dash, as a dashed lines, continuous dashed lines, and O dash and P dash is also as an invisible edge. Got it? Next, what happens to the slant edge O dash and A dash? It is forming an outline. So therefore, it has to be a continuous line, whereas O dash and C dash is also an outline. You have to show it as a continuous line. What happens to O dash and B dash? O dash and B dash is nearer to the observer, which is visible in the front view. So therefore, O dash and B dash is also a visible edge. So this is how you are going to complete the final front view. Okay, and of course, don't forget to show the axis over here. So the axis should be represented with axis representation O dash and O dash. Got it? So this is the completion of the solids or the third position front view. So please make sure that you have shown the visible edges, invisible edges, and the axis, because each and everything will carry their own marks. So please don't use the marks here without just not showing any one of these. This is the completion of the first problem, that is a pentagonal based pyramid resting on HP with one of its base edges, and the axis is inclined to both HP and PP. So this problem is we have to consider, or we have to complete the projection by taking the PCAM. Yeah. So any doubts, any clarification by the students, you can ask me. Yeah. to ask clarification. Okay, so if you don't have any clarification, I will take to the next problem. Problem on 7 is yeah, complete that. Uh, we'll take 5 minutes break and I will just continue with the problem. Next problem. Okay. So it is around 9:22 now. So I will come back by 9:27. Okay, so complete that problem. So take 2 3 minutes break and I will come back to it.